Well, good afternoon, good evening, good night, wherever you may be across our lovely planet. Thanks so much for joining us here live again for the one and only Serverless Office Hours. Super happy to be talking to everybody today, and super awesome to have two lovely guests who we always welcome on Serverless Office Hours. We've got Dirk Freuner. Dirk, welcome to Serverless Office Hours. I'm trying to remember, have you been on Office Hours before, or is this the first time pleasure we have?
Hi, Julian. No, unfortunately, it's the first time, but hopefully not the last time.
No, absolutely. So yeah, well, Dirk and Christian is joining us as well. Both Dirk and Christian are in Germany, so people in Europe are finally taking over fully office hours for this episode, which is always great and fun. But yeah, Dirk, tell us what is your journey? Awesome, perfect timing, excellent, Dirk. Yeah, tell us what's your journey to what you do at AWS.
Right. So actually, I have just moved teams. So after I spent 7.5 years in the enterprise team, during the past years, mostly looking after power and utilities customers, I have just moved to the ISV team. So now I'm working with software companies on their multi-dimensional transformation.
Okay, that sounds interesting. Yeah, 7 years at AWS in one team. That's I think that's like dog years. When in human years it's about 50. So yeah, well, must be fun having some new challenges. And Christian in a slightly different part of Germany in Frankfurt. Yeah, welcome to Office Hours. Yeah, what's your journey to do what you're doing on AWS in the world of serverless?
Yeah, hi Julian, hi everyone. Yeah, similar to Dirk, I'm also a principal solution architect with AWS within our automotive vertical. And I have the pleasure of supporting our customer BMW exclusively for the last 3 years and helping them to build and optimize applications for the AWS cloud.
Christian, I think that is probably your dream job. I think the number of times I've met before, and you're definitely fashion branded with BMW stuff, and I know you're a fan, so that must be a cool having your personal passions and your work align, which must be fun.
Yeah, when I joined the team, colleagues mentioned this is match made in heaven. Yeah.
Excellent. Well, just before we get on to the awesome stuff that Dirk and Christian are going to be talking about today, just having a look back at the last week or so of what's been happening in the world of serverless. Last week I was on holiday, so Eric Johnson, the awesome Eric, was filled in, and he was talking to Elad Ben Israel, talking all about developing with Wing Cloud. If you're not aware of Wing Cloud, well, all the information is on the previous recording, which is on youtube.com/serverlessland, along with all other recordings. And yeah, Wing Cloud is awesome. It's all about sort of abstracting and merging application code and infrastructure code into one kind of thing. So yeah, super useful, interesting stuff. And Elad was the original creator of the CDK, so a long pedigree of building cool stuff on AWS. In terms of what's new in the world of AWS, if you are using step functions, which you really should be looking at, more and more integrations to do more and more kind of things. And if you're doing anything in the world of media, maybe AWS Elemental Media Convert may be a service that you've been using, and now it's even easier to use from step functions. The second one down is slightly interesting because even though it's not quite in the serverless world, it's sort of CloudFront. But if anybody's using Lambda function URLs, well, CloudFront has added OAC, which is Origin Access Control for Lambda function URLs. This basically makes it a little bit easier to be able to secure your Lambda function URLs, because you can have them IAM auth publicly available on the internet, and then the CloudFront can actually do that SIG-v4 signing. So yeah, just another way that you can use the sort of really simple, easy to use Lambda function URLs, but have a bit of that security as well. And also Cognito, lots of people using Cognito at very high scale, and now you can use Amazon verified permissions to use that as well, which could be helpful for you as well. And if you're a Ruby developer, Ruby 3.3 is out for Lambda, so certainly helps, and it's actually pretty easy upgrade. There's not a lot new in the whole Lambda world, other than it being on the Amazon Linux 2023 operating system, which has some advantages as well. But otherwise, it's just the new stuff in Ruby 3.3, which is the cool Ruby stuff is available. In terms of some blog posts, yeah, lots been going on in Q1 this year. I put together a blog post which has all the details of the various media streaming things we do, in blog posts and releases and events that are coming up. So yeah, a nice sort of one-stop shop that you can gather all that kind of information. In terms of events, it is AWS Summit season, and I know Dirk and Christian were at the Amsterdam Summit last week. I will be at the London Summit next week talking, and I know Dirk and Christian, you're also going to be in the Berlin Summit in May. So just as a teaser, what are you going to be talking about in May in Berlin?
So can go first. Yeah, I have the pleasure to co-present 2 sessions with, of course, my customer BMW, where we talk about BMW's software factory and their winning strategies to maximize their value by leveraging AWS. And then also a second session where we talk about BMW's approach to scale software-defined vehicle using cloud-native tools in AWS.
Well, certainly sounds interesting. And Dirk, what are you talking about?
Well, I will be continuing my world tour with Gregor Hoppe about integration patterns, and we're going to talk about that 2 times there.
Excellent. Fantastic. Well, remember, all AWS Summits are free to attend events, lots of great technical content. I know behind the scenes, there are a lot of people making sure that the content bar is really, really high. So yeah, that should be great and be able to connect with lots of people as well. Close to home, for me at least, in London, EDA Day in London, Event-Driven Architectures Day in London on May the 14th in CodeNode. That's slap bang in the center of London near Liverpool Street Station. Really easy to get to. And yeah, we did the first one there about 1.5 years ago. Was sold out. A really useful day, all about different ways that you can consume and use events across AWS. So yeah, really useful. I would suggest you sign up for that and come and see us all in London. But today we are talking about serverless messaging services. And although it's combining, I thought I'd actually change that to using serverless messaging services. Of course, you can combine them. But Christian, serverless messaging, decoupled systems, there's a whole bunch of stuff we can talk about. What should we be thinking about first when we're thinking about serverless messaging?
Yeah, maybe first of all, let's share what is the focus of today's session in terms of our cloud-native serverless services, where we will mostly talk about Amazon SQS, SNS, and EventBridge. And for participants who are mainly new to AWS, so Amazon SQS, our simple queue service, which was, by the way, the first AWS service launched publicly back in 2004. And it allows us to implement persistent point-to-point communication by using queues. We also will talk about Amazon SNS, our simple notification service, which implements a publish-subscribe pattern, so allowing us to fan out to thousands or even millions of subscribers using topics. And last but not least, we will also talk about EventBridge, our serverless event bus, enabling us to build event-driven applications and scale across AWS services, existing systems, or even SaaS applications.
Excellent. So yeah, two things I always like to say is that we know people all think that serverless is a modern thing, but actually, our two first services at AWS were SQS and S3, and 100% serverless services. And so I sort of say that the cloud was born serverless, and then virtual machines and containers had to catch up a little bit later. So. And I know, so that was the one point I wanted to make. And then the other was, we're talking obviously different kinds of services, but obviously there's a reason for using these different kind of services to tie together application architectures. And I know we're going to talk about that later, but also, there are other types of application architectures, such as streaming with maybe Kinesis or maybe with Kafka. Kinesis is sort of quite serverless as well, but how does one think about, there are many different ways to connect applications together. How would one think about the services we're going to be talking today, SNS, SQS, and EventBridge, compared to some of the others?
Yeah, good question. That's also a question customers ask us quite often when we talk about messaging services. And there are some fundamental differences, we would say, between messaging and streaming services. And when we talk about messaging, we have a use case in mind where we consume an individual message or even a batch of message, but each individual message is a unit of work and has some value to us. So this could be, for example, in my context, I usually work a command message requesting a car to unlock a door. Or it could be a document message containing a specific vehicle configuration. And we usually cannot afford to lose one of these messages. And in contrast, when we talk about streaming, we never consume individual messages, rather always a batch of messages coming from a virtual infinite source, a stream. And a single message could be, for example, a sensor measurement and only carries limited value to us. And usually you will look at a large amount of messages to get value out of it by running some type of analytics or other calculations across a large amount of messages. And if you would lose a single message, it doesn't have an impact on our overall processing. And there are also some technical differences between messaging and streaming, and the most prominent one here is in messaging, a message will be deleted by the consumer after successfully processing the message. And in streaming, a message only gets deleted by the streaming service when it reaches its retention period. And usually it takes days, weeks, or even months. And therefore, all message consumers in a streaming or leveraging a streaming service have to maintain a pointer to a specific position in a particular stream and also update this pointer, so moving this pointer forward when successfully consuming and processing messages. And of course, this pointer needs to be persisted so that it can survive an application restart. But this also allows us to replay messages from every point between the beginning of the stream until the last message in the stream, if you have to. So these are usually the fundamental differences we are pointing out between messaging and streaming. So maybe Dirk has to add something, but I think I covered this.
Yeah, maybe the mental model we can also use here could be quite helpful. So with messaging, you get the overall picture with one entire item, the message. And in streaming, you would typically need a batch of messages to get the entire picture, in this case, to construct this entire picture of the two of us. By the way, if anyone has an idea where this picture was taken, please just drop it in the chat. There's no prize to win also, but it would be interesting if somebody recognizes it. And
we can give a prize to win. We can actually give we can give everybody 1 million free Lambda invocations every single month. That can be our prize.
That sounds great. That sounds great.
Basically, that's free for everybody anyway. So this is a bit of a participation prize. But,
yeah.
And thanks, Alpacodes, for joining us. Yeah, from Twitch. These are nice, clear explanations of the differences. Well, thank you to Christian and Dirk.
Yeah, maybe just to point this out, there's, as you can think about it, there's quite some ambiguity between going for messaging, going for streaming. As Christian turned out, there are nuances in between, but the decisive difference is the consumption model, and maybe also on the streaming side that you typically need to work with partitions in some sort. Depending on the product. But now, since we have archive and replay also for certain fan-out channels on the messaging side, it makes it even more ambiguous to understand, should we go for messaging or should we go for streaming? But even if there's archive and replay for messaging, the consumption model still remains the same, and that's different than in streaming.
Yeah, and even I'm thinking like if you're using SQS, which is you're probably consuming individual messages, even though a Lambda function may receive a batch, you're actually processing the individual records within that batch as separate messages. So yeah, there's enough complexity in this, but these are the sort of architectural patterns. So just then on to another question I'm thinking of is, why are AWS customers, why should people use serverless messaging services? I mean, maybe people are building microservices and they know that maybe they need to connect between the things and they're using APIs and all these kind of things. But sort of, what are the advantages of using a serverless messaging service?
Yeah, I would say the typical advantages for our serverless services apply here as well. So not having a downtime to care about when there's a need in patching the operating system or maybe in messaging service. So for example, if you compare this with Amazon MQ, you have to have your maintenance window in mind, and it maybe take longer than you think if you have to fail over to the standby broker. Then in most of the cases I have seen working together with even large scale customers, it's a more cost-efficient solution. And in most cases, more cost-efficient if you just look at the AWS cost, but even more cost-efficient if you take a look at the total cost of ownership, which also takes into account to maintain the service, to scale it, to patches, and so on. And of course, last but not least, also because these services scales automatically, it has also a huge advantage, even in terms of reliability for our customers, because they don't have to have all these auto-scaling configurations in place to scale out maybe their messaging solution. It just scales automatically for you. So I would say that's probably the most important reasons for our customers to pick these serverless messaging services.
Okay, so that sort of definitely answers the questions. Why would you go serverless? Because obviously you've got maybe unpredictable workloads. You don't want to do any patching. Cost efficiency and that sort of scale automatically. But the second part of the question is, why even use a messaging service? And you've mentioned, SNS, SQS, and EventBridge, all have their sort of unique features and advantages. And just before we get into the individuality of each of the services, what are people using in general messaging services to connect between?
Dirk, do you want to go for this one?
I can go for this one. So, for instance, if you think about Amazon SNS, you can use it to fan out your messages to thousands of subscribers. Very simple. The producer, so the system that sends messages into the channel, doesn't have to know anything about who is actually consuming those messages, right? So SQS, for instance, it is used for point-to-point messaging, and here comes into play that SQS, so those queues, buffer the messages for you. We will see an example later also what that means and what are the benefits for this, but they keep the messages for you. And the very first thing that comes to mind is if the consumer is down, be it for planned or unplanned maintenance, the message is not lost, right? It is stored in the queue and it is available later, or also the message consumption processes can decide on their own pace how to consume those messages. If you look at Amazon EventBridge, it is really easy to consume third parties or AWS service events, validate messages against schemas, for instance. And then you have EventBridge pipes, which you can not only use for filtering, but also to enrich or transform messages while they run through the system.
Okay. But in general, I would say to decouple systems.
Okay, and part of the reason for that decoupling is because you want to protect producers from consumers. Maybe you want to be able to have individual teams to be able to work on their own individual microservices and just know that they can build their microservice in isolation. But as soon as they need to coordinate with another microservice, they can use these messaging services to communicate between them well without having to worry about the scalability and all the infrastructure that need to run. So I know we always get lots of questions like, which should I use? SNS, SQS, EventBridge pipes, that kind of thing. And I just was writing down some notes while you were doing it. And so I'm going to just put them on the screen because they said, so you said basically SNS, if you're going to use fan out to thousands of subscribers. So that is, you've got in a way a single consume or something is going to send a message and you've got thousands of subscribers that you need to send to. And so SNS is going to be low latency, quick. And so the fan out is a lot of different messages. Is that the sort of high picture of that?
That's right. Although it is not like a precondition that you have to have thousands of subscribers, right?
Okay. Yeah.
It also makes a lot of sense if you only have 3 subscribers. What we're going to see in an architecture example in a few minutes. The point is that it is possible to have thousands of subscribers, even millions of subscribers, and that it is super simple. It is ridiculously simple to use, right? And the same applies to SQS. It's also ridiculously simple to use. It's a super simple API. You have only a few primitives. I've heard primitives is a big term currently, looking at the letter to shareholders of that NUJC sent out recently. But and primitives have been basically in our history already when Amazon.com broke down the monolithic applications that we had like 20 plus years ago or so. We also decided to expose primitives over simple APIs, and SQS and SNS are examples for that.
Okay, and then SQS, when you were saying it's sort of for persistent async point-to-point messaging. So I think of this in my head is you want to decouple a system and you want to have a buffer, a queue in the middle, which can protect a downstream service, or you have no idea how many messages are going to load in there. And I think SQS is infinitely scalable, so you can dump anything on there and then at your own rate consume messages asynchronously from that. Is that a good mental model?
Yep, definitely.
Okay, cool.
And I also can share a slide here, Julian, where we try to visualize different features of SNS, SQS, and Event Bridge.
I'm going to bring up that slide because I can see it, and I know what it's going to go into it, but I know people are going to look and they're going to be reading carefully, and I want to spend time on that. But just to bring up the two last things, because you mentioned Event Bridge, and Event Bridge is about consuming third-party or AWS events to then route them around against a valid schema. So this is, in a way, a sort of new, different way of doing things because, Event Bridge just has all those AWS events. So if you're doing any IT automation or you're reacting to anything that AWS does, this is just a service that's built in. And then also the cool integrations with all the partners. So you want to, get information from Zendesk or from, who did we have on recently? Or even, who did we have on recently? My brain's going mad. A whole bunch of third parties. I'm thinking of one we had recently on Office Hours, but a whole bunch of third parties which you can get information from. And then the last I think you mentioned was Event Bridge Pipes, and this is a bit more of a managed service where you can grab data from a whole bunch of services that it pulls from, and then you can also filter, enrich, and then send that on to another service. So those were the four kind of things. But this is the slide I know you had prepared to talk about the integrations of all the kind of three. And I know people are sort of squinting to look at all the different kind of things. And my first reaction looking at this is like, why don't we just build a service that does it all? Why do we even need different services? Surely there's just one service that can be built to do this all.
Yeah, good question. And I think that the challenge our customers and also we as a solution architect working with our customers are facing is all these services adding, of course, new features and functionalities based on customer feedback. And this also leads to a much larger overlap of all these messaging services than a couple of years ago. So, for example, we just recently also added message filtering on an SNS body, for example, which in the past was just a unique feature of Event Bridge. So what I would recommend how to read this visual, and it doesn't mean to be complete, is try to figure out whether you can find a unique need or request from your customer, which is uniquely provided by one of these services. So, and you mentioned already some of these features. So, for example, if you have a need to fan out to thousands or even of millions of subscribers, so SNS is most likely is a service you will end up. Or you also mentioned if you want to consume third-party events from our third parties we integrate with Event Bridge or even AWS service events, that's so easily if you use Event Bridge. And if you would like to implement a point-to-point messaging which is persistent, which also acts as a flattening load balancer, for example, to protect your downstream systems, of course, SQS is most likely the service of your choice.
Cool. And thanks. I think it's Surab. Apologies if I've messed up your name. Yeah, very informative and cool slide. It is a cool slide. The thing I'm thinking of as I'm looking at this as well is actually what you need to do. I think what you need to do beforehand is actually understand your architectural patterns before actually picking a service, because I can see many people thinking, oh, well, SNS does everything or Event Bridge does everything, and going along this pathway when actually there are very common application patterns that have been encoded 20 years ago. Dirk and Gregor Hoppe are doing talks on Gregor's patterns that he codified 20 years ago. So would you suggest to customers that they actually need to understand their architectures and what they're going to do to be able to realize whether if they are doing fan out or whether they need a persistence queue and flow control and all these kind of things before they actually start picking services, because then they're going to understand what they actually want to build before picking a service?
I can absolutely agree to that.
Right.
When I talk with customers, I try to defer talking about concrete services as much as possible. I prefer to talk about patterns first, and then derive a concrete service for every use case from that.
Okay, so I mean, what are then typical patterns that maybe customers can think of beforehand for their business use cases?
Christian, do you want to take that one?
Yeah, maybe let me start with the first pattern, which is called topic queue chaining. So
there we go. Yeah,
exactly this one.
Okay.
So because we're also talking about how to combine AWS serverless messaging service, and that's a good example how you can combine SNS, which provides a topic semantic, and SQS, which provides a queue semantic to achieve a certain outcome. So if we start on the left side, so we have a producer sending messages to a topic. And then we have a couple of consumers consuming the exactly same message. So a topic has a semantic that an individual message is sent to every subscriber of this topic. So here visualized as A, B, and C. And this is good. But if you have a situation where your producer can produce messages in a faster pace than your consumer can consume and process these messages, you're probably wondering how you can scale out on your consumer side. And just by adding an additional subscriber here will not help, because this subscriber will also receive every message. So it doesn't really help you to scale out. And the pattern you can see here, so chaining a topic and the queue, which is shown here in the middle, will solve this problem, because when we subscribe this queue to a particular topic, this queue will receive all the messages, so ABC in this example, and then you can have multiple consumers consuming messages from this particular queue, and all these consumers then are competing about these messages, which means only one consumer will see message A, only one consumer will see message B, and so on and so on. And this pattern allows you to have a fan out, but also scale on the consumer side if you have to.
Okay, and I suppose you've got filtering on the topic side as well. So yeah, there's a lot of clever functionality you can do, and you've got this massive plan out with SNS, so you can send it to loads of subscribers at hugely high scale, but your consumers can be sitting there going, oh heck, I'm not quite sure how to consume this. So you put a queue in the middle just to calm things down and sort of balance out that workload. Okay, no, I like that. So that's topic queue chaining. And actually, I forgot, how was I silly? We are live in office hours, obviously. So please send us your questions, your comments. We love to hear from you. We've got a few people who have joined as well. Naram Sitam, thank you for joining us via YouTube. Hello, folks. Daniel Abib, always welcome from Brazil as well. And of course, awesome colleague as well, who I could never forget about, is Ben. Hello, Ben. Nice of you to join us from Brazil. And Brazil seems to be doing a good showing as well. Jose Vicente, hello from Brazil as well. So yeah, always love to hear where people are coming from. So topic queue chaining. There was a question. Sorry, I did lose it. I want to bring it up. The Tech Guy 21, thanks for joining us again via Twitch. If the subscriber is not available when the message is sent to SNS, will it get it after it comes back up? So I think this also leads into this topic queue chaining, a good use case.
Yeah, it goes a little bit also on the topic of durable subscribers, because usually subscribers only receive messages after they have subscribed to a topic, which means if there's a message sent when a subscriber is not subscribed, it will usually don't see this message. And using the topic queue chaining is a good way to solve this issue, because of course our SQS queue will be subscribed to this channel, and then it will store and buffer the message until your subscriber comes back online and is then ready to consume this message.
Okay, excellent. So yeah, Mika also joining from the NAB show in Las Vegas. Thank you for joining us. And also an interesting thing I think lots of people wonder about from Narim, queue filtering or topic filtering on the slide. Where do you do your filtering then?
So usually you do the filtering in the subscription. So if you subscribe a queue to a topic, you have a possibility to express what type of messages you would like to receive. So for example, just from a specific service or just from a specific event. So I would say it's sitting between your topic, which receives all the messages, and between your queue, which only receives messages you're interested in.
Yeah, and I think you've got to think about where your messages are coming from. I mean, always also think about, you want to drop messages as soon as possible as well, because it's pointless a message going through 2 or 3 different services. And if you can drop it earlier, so if you know at your SNS topic in this example that you're never going to use message C, well, you can drop them straight away at SNS, and then maybe you're going to do some further filtering down the further along in your workflow. So we've done topic queue chaining. What other sort of typical patterns is it worth thinking about?
Maybe not so much about the patterns, but other combinations of these services we see is, for example, as we mentioned before, event, which is most likely the service you will pick if you, let's say, produce third-party events or maybe even AWS service events. And let's say you have a need to fan them out to maybe not thousands, but maybe tens or maybe hundreds of subscribers. And that's then probably also a combination of using EventBridge for consuming these messages and then handing over to SNS, which is very well set up to fan out these messages to tens or even hundreds of subscribers. But you could do this with EventBridge as well. You have to build this cascade of rules to be able to achieve the same scale as SNS just does out of the box.
Okay. So yes, that's combining then, EventBridge to use all of those third-party events or even AWS events, and then using M&S. British people will laugh about using M&S, but I'm using Amazon SNS for the thousands of recipients.
Yeah. And then maybe a third example I can give you as well is also, let's say if you have an API gateway, and not sure whether Dirk will talk about this a little bit later. So there's a direct integration between API gateway and SQS, for example, to quickly respond to an API request where no response is expected, just making sure that the request is captured by your service and will be processed eventually. And just handing off this message to SQS because there's a direct integration, as I've mentioned. And then you could use, for example, EventBridge pipes just to consume this message from SQS, to transform it, to enrich it, maybe to filter it, and then just call another third-party API to process this message. So this could be also a good use of combining 2 of these services like SQS and EventBridge pipes.
Yeah, I like that integration as well, because API Gateway is super scalable, have that on the public internet, but you've got a lot of messages coming in. You don't need to respond about the messages. You just need to store them. SQS is that great store, that great buffer, and then, using EventBridge pipes for filter transformation enrichment. I like that pattern. Something, we keep talking about SQS, and I love the idea as a buffer, but also, sometimes you need to throttle things. You don't want to overwhelm, some downstream systems. So to tell us about how SQS can be useful for that.
So as mentioned before, so SQS scales with your needs. So if, let's say, you have a producer which is producing messages much faster than a consumer can consume these messages, you can put, and maybe if you can share my screen again.
Yeah, certainly.
So this probably helps. So you could put a queue between your producer and consumer, and you can, for example, if we leverage AWS Lambda to consume messages from this queue, you could set a certain concurrency for your Lambda function, where you know this is a rate. You can call maybe downstream systems to enrich the message or just to forward the message. And then if your producer is producing messages at a much larger scale, what will happen is the queue depth, which means that the messages in your queue is made growing while your consumer is consuming at a fixed rate. And then when your arrival rate in your queue drops, your consumer is catching up at some time. When the queue is empty, the consumption rate will may drop to 0 until there are again messages in your queue, and then your consumer is scaling out to the limit you have set and consuming these messages. And this is one way how you can protect your downstream systems from getting overwhelmed with a producer which is just flooding your system.
So yeah, that's a predictability. So I know, Dirk, you're always a big fan of talking about integration, and I love the way you sort of talk about that. So we're talking about the different services, but you know, people need to think about, as we've spoken about at the beginning, taking a step back and looking at the architectural patterns. And I know a lot of people talk about the different boxes. We've got producers and consumers, but it's often the lines in between the two that are important for people to think about. So I know you've got some things you want to share with us about how to think about the integrations.
Yeah, exactly. So we can simply start with a nice quote that is waiting on my slide, and you can share.
I don't think I have your screen share up. Do you want to just share
You
your
don't?
screen again? No,
Did it drop?
Maybe,
Okay.
maybe it dropped. It's running around the internet somewhere.
Yeah, we can fix that, I guess.
We'll get there. Well, actually, a question did come again from Naren. You know, when do you use EventBridge versus your own custom enrichment processing? I will say, if you can use EventBridge, go for it, because there's just less code to manage and code to run. If EventBridge pipes is going to work for you, off you go. But you know, if you do need some further you know, custom code, or you're specifically sending it to a destination that EventBridge doesn't support, then you need to use something else. We have your slides, Dirk. Yes.
Okay, so it's a nice quote from our colleague Gregor. So in modern applications, be it cloud applications or not, integration isn't an afterthought. So you may think on one hand, you have a landscape of microservices or self-contained systems. I know the term microservices is maybe a little overused or so, but it's a reality for many folks. But that's not the only case where you need to think about integrating systems. It's actually that every company needs to think about integration, because every company has multiple systems, and that might be monolithic systems or so, internally and also externally. You need to integrate with third-party systems, you need to integrate with SaaS systems, and so on. So you cannot just leave the integration thought behind you. You need to think about this from the very beginning. And this is why it is so important, I believe, to have a good understanding about it and keep it in mind.
I thought there was just if you can go back to the previous slide, I thought there was a spelling mistake on that, but reading it again before I put my sounded silly with Gregor being an application architect. I thought, there must be a spelling mistake, but I see the integration and the application coming together, which
you got it. Yeah, that is the point nice. Here, yes. Yeah, I think so too. It is nice, actually. Right, but as I started saying already, you know, this integration scenario might be super simple at first sight. We have two boxes that we connect with each other. But then if you look at the options, from a technology perspective. We have file transfer. File transfer is all around us, so everybody has to deal with it somehow. We have APIs and all their cranky uncles. What do I mean with cranky uncles? I mean stuff like SOAP, which is definitely unpleasant to use. Then we have messaging, streaming, and so on. And maybe we need to think about how to put everything together. That is choreography or orchestration. So there's a lot of things to tackle here and to understand here. But then also, if you look at this again, once you chose a technology approach, now that's also a style that you need to think. And how do you put this into practice, right? Do you have a synchronous or an asynchronous integration? What is the interaction model? Do you push something? Do you poll something? Idempotency, is that relevant or not? Error handling, it probably is. So you need to consider all this, and all of these approaches have their pros and cons, and that also depends on the very context you're currently in. And this brings us basically to this insight here that I have written down, that whatever you do, there is a trade-off to look at, and you need to understand the trade-off. And the bad news here is actually that whatever architecture decision you take, there's always something that sucks. But as an architect, if you understand the drawbacks, you are able to identify the least painful option on the table. I know our mental laziness brings us to some point where we just want to have it all at once, but you will never get it. There's no tool that brings it all at once. And that is also the reason you asked that before, Julian. Why don't we have just one integration service for everything? Well, we could build one that implicitly you decide, do you have a queue? Do you have a topic? Do you have a bus? Whatsoever. But that doesn't help. There are still those primitives that you need for certain use cases, that one primitive here, that other primitive there. And in the end, the good thing, and we touched this a little bit already, we can also look at those serverless integration service from some durable needs that we have as developers and architects when we build systems. Because what we've seen before, there is a lot of functionality that you just get from those services that you would otherwise have to implement on your own. So there's a durable need to reduce the lines of code if you are a developer, right? You can shift away the operational responsibilities from that messaging systems, in this case to AWS, to have SQS, SNSO, and RentBridge take care of this, right? On the other hand, on the left-hand side, if you build a landscape of microservices, you have the flexibility for evolution in each of those systems. So that's good. And then you integrate them with those serverless messaging systems. And if you can increase the overall reliability or scalability and whatever other ability of your overall system, you increase the end customer experience. And by, again, moving the operational responsibilities to AWS, you can focus more on your business value. Does that make sense?
Yeah, no, that definitely makes sense. I like the picturing of that. But I mean, we're still talking about architectural patterns. We're talking about services. So, what is a good way to navigate the different features, and what are some of the fundamental aspects people need to think of, and sort of general considerations for ultimately picking services?
Right. So I believe, and Gregor and I tried that out in our current talk about integration patterns. If you take it from some fundamentals of distributed systems and consider each of them, you can get a good understanding in what aspect those messaging services can actually help you. And for instance, we have the coupling aspect. This is definitely the one that takes most place in all those considerations. So I can go through an example how messaging can help here to reduce your coupling. Control flow and flow control, Christian already showed that message queues are traffic shapers, so they can flatten peak loads. We can also quickly look into that. And then we have those nasty things like message order and delivery semantics, like how often delivery, We have error handling and replays. And then we have tools like that letter channels. We heard about archiving. We have the fantastic idea of idempotency in consumers, and we have deduplication. These are all things that messaging systems can help you dealing with. Right. So if you want, we can quickly go into one example to look how we can reduce coupling between systems. Okay, and the example is from the context of our most famous fictional technology startup, Wild Rides. I guess many of you have heard about it. So it disrupts individual passenger transportation by replacing old guard taxi cabs with unicorns, because it's a lot more fun and a lot more magical to ride unicorns. And we will have a use case for ride booking. And we will use this to show how we can reduce coupling between systems. And coupling is actual integration's magic word. What it means in the end, you have less coupling if you don't have to do a lot. When you change something on system A, then you don't have to do a lot on system B to adapt to it. But it's not binary, so there are different grades of coupling, and there are, for instance, also a lot of dimensions. If we want to dive into one example, we have the temporal dependency, which is synchronous versus asynchronous integration or coupling. So let's have a quick look at the ride booking use case. For that, we apply the synchronous request response pattern. So we have the Wild Rides customer that uses the app to send out all the details for a ride booking. So from where to where do they want to go and when, maybe next week or so. It lands in the ride booking service. And then, since Wild Rides is a modern company that uses a microservices landscape and so on, the ride booking service doesn't do this all on its own. But there are a lot of downstream systems that also take care of all this. And in the very first version of this architecture, they use synchronous API to integrate everything with each other. So as we can see, each processing step in each of those downstream systems takes a while. And since it is synchronous, it all takes a while, particularly it accumulates until the customer also receives a response. And every system that sends a downstream request is waiting, since it is synchronous, is waiting for the response. So we bind resources along the way. Okay, so that means we have a lot of coupling between all those systems. A lot of coupling can also lead to a lousy user experience. In this case, the customer needs to wait quite a long time. And this is why I also sometimes call it lousy coupling in contrast to loose coupling. So, well, as I have said, we have synchronous integration via APIs using the synchronous request response pattern. Now, what our customer, Wild Rides, experience with this is then when a downstream system reaches its limits, they observe that also preceding services in the request chain require scaling. And this is because of the tight coupling at runtime while one request is running. A way out of this could be to replace the synchronous request response model with the asynchronous request response model. That means we just send out the response, and the downstream system just provides an acknowledgement that it has received that request. And it is even possible to do that with HTTP. You can use the onboard means for that. You respond with 202 accepted. And the first thing is that we fix the user experience and we directly respond to it. But then also under the hood, we can send out asynchronous requests to all those downstream systems. Maybe except the external payment service provider. We have no influence on that one. Right. So are we missing something? Yes, the responses. I was omitting the responses on this slide to keep it better digestible, but I will add it. I will show you the responses also in a second. Are we still missing something? Yes, and this is the trade-off for asynchronous integration. You need the downstream system to know where to send the responses. That means you have to inject some meta information, which is called the return address pattern. And also the original sender needs to know how it can match an incoming response to a previous request. So for that, we imply the correlation ID pattern. So we would just add this to all those requests. So that's the additional trade-offs that we need to do here. And also to keep somehow our outgoing requests persistent. But with that, our sample customer has reached a state where they can also handle large load on their system without losing stability of the overall system. And that brings us to the insight that friends don't let friends rely on synchronous integration. But we are talking about messaging here, right? Now we have the availability dependency, which is quite crucial here. So if you look back at the architecture as we had it so far, let's say the write payment service gets into trouble. And this is where now messaging comes into play. So if you compare asynchronous request response with APIs to messaging, the message channels now have an indirection or enter a means of indirection between requester and responder, and they become less coupled from each other. Christian has talked already about queues, and those can come in handy here because they buffer messages. So going back to the original architecture, let me now simplify it a little bit by removing the second level of downstream systems. We now have the asynchronous HTTP request, and we can just replace it with a queue for each of them. And now I'm also showing you the responses. So each of those downstream systems sends a response back to the write booking service. All right, so that was that. But then we still have other dependencies, like the location dependency and the semantic dependency. Like so far, the write booking service needs to know all of those downstream systems, right? And probably it is also sending typed requests to all of these. Like every of those messages contains maybe a little bit of a specific payload for the Unicorn management service, the write payment service, and so on. Now we can go for topics, and then we can also implicitly remove our thinking from requests to more of events. Like we have the same kind of payload that we send to all of those downstream systems, and we don't have to know which of those systems is actually listening. But then again, we would jeopardize the availability dependency that we just gained. Now, this is where the topic queue chaining pattern comes in handy. And we have the best of both worlds, as Christian has just shown to us. So with that, we have really reduced the overall coupling between all of those systems a lot and super easily by just turning our communication model to asynchronous and by switching from APIs to serverless messaging.
Excellent. I love that. Yeah, that's a great use case in sort of explaining and bringing it to life. Now, we only have a few minutes left, and I just want to quickly see if we can, literally spend a few seconds on each of the kind of things. I know you were talking about control flow. How would one select between a pull, a pull-based and a push-based thing? And I think that's on the control flow. But yeah, we don't have that much time, a minute or so. So what would we say about that?
Right. I would maybe want to use that time to make everybody aware of there's not only control flow, but there's also flow control. And if you work with queues, you have to look at flow control, because if you have slow consumers and fast producers, your queue will fill up. And then there are two handles that you can use. The first thing is the time to live. So you might decide that after a certain amount of time, even a valuable message may not have a meaning to you, right? At a certain point in time, okay, if I haven't processed it till now, then I can also throw it away. But then there's, and that is something that you have implicit with your messaging system. But the other thing, on the left-hand side, you need to take care of yourself. So this is producer flow control. You need to somehow instruct your producers to slow down. And that means you put back pressure on them. And this can be in an automated way that you look at the queue depths and then send out notifications to your producers, hey, please slow down a little bit. Or you can do it really explicitly like folks do it in a coffee shop. And we can even see it in the serverless espresso case. So in the step functions workflow that we have in there, we have a choice state capacity available. So if we have already too many orders that would overwhelm our consumers, which are the baristas, we put back pressure on the customers. They are the producers that put messages into our queue and tell them, okay, for the time being, we don't accept more orders from you, unfortunately. And this is how Serverless Espresso does it. This is what you also see at Starbucks, for instance. And by the way, Julian, do you recognize yourself on that photo?
Ah, I do actually. That is funny. Peeking between all the people. Excellent, Dirk.
Exactly.
Like literally for a few seconds we have. I know we wanted to talk about ordering, and I know there's a whole bunch of stuff, but I think we can just quickly say that SQS and SNS both have FIFO, first in, first out. So if you do have strict ordering requirements, those are services to use. If you're using SQS, SNS for standard channels and EventBridge, there isn't any guaranteed kind of ordering. But just quickly, even Christian, what's your take on deduplication, at least once processing, item potency? You know, do you have any quick hot takes that people could think about for that before we have to say goodbye?
As you mentioned, SNS 5 for SQS 5 for it will take care about deduplication when you send message to the service, so in a 5-minute interval. But on the consumer side, you also have to think about it. So if you consume a message, it could happen that you just process the message, but before you acknowledge back, maybe your processor failed, and therefore item potency is quite important. But when you're consuming messages from an SQS queue, there's also an attribute called approximate receive count, if I remember correctly. And that's maybe an indication of whether you received this message a second time, and maybe you then execute some additional code just to make sure you don't process the message twice.
Okay, excellent. Yeah, and I'll just jump in there because Jose also said how to handle item potency of the messages. So some strategies. Some of the services have these built in as well, but also if you are using your own code, Lambda Power Tools has a library. There are other libraries, so you can use this in your own code where you basically handle part of the item potency for you, but Power Tools makes it super easy. I feel as though we could have gone on for many hours. There's so many integration patterns, and I know we had some things to talk about additionally. So yeah, unfortunately our time is up, but Dirk and Christian, we appreciate so much the knowledge you've had today. This recording is going to be available on the YouTube channel as soon as we finished, but thank you everybody for watching. Actually, next week, just quickly, we are actually talking about building real-time apps with EventBridge and AppSync. We've got Josh Khan on the stream next week. So Dirk and Christian, thank you very much for your time, and everybody, see you same time, same place next week.